Clark here at Killer Fun, back with another Artisanal Sudoku Solve video. This puzzle is 91 by James Sinclair from the Artisanal Sudoku Substack Newsletter, volume 224. For you to play along, it will take a couple of additional steps. The link to play this puzzle is in the newsletter, which is subscription only. It is a free subscription and well worth the effort to subscribe. James has amazing puzzles and doesn't spam. You will receive one email on Monday with new puzzles. If you wish, you can upgrade to the paid version, which provides even more excellent puzzles and content from Artisanal Sudoku. Use the affiliate link in the description to subscribe, or just watch and enjoy. Let's look at the puzzle before we start solving. The first thing to notice is that 72 out of the 81 cells are grayed out. We'll see in the rules what this is all about. Also, column 1 has killer Sudoku Cages starts and sums. I say starts because we don't know for certain the number of cells in each cage, or how the cage might turn or expand, which adds an interesting twist to this puzzle. We can see that there are no cage boundaries on the right side of any of the cells, so all of the cages must at least contain 2 cells. One thing that you can't see, and which I won't reveal, is an additional bit of information from the newsletter that might help in this solve. I'm going to demonstrate a solve path that doesn't use that information. Let's review the rules. First, Sudoku rules apply to this puzzle. Second, the grayed out cells are called dynamic fog, which reveal cells when correctly set and potentially other cells to progress the puzzle. Third, killer Sudoku cages. And finally, if you see an X placed between 2 cells, the numbers on either side of that X sum to 10. Now, on to the solve. I'm excited to walk through this logic with you. And let's start here in box 1. In box 1, we have the beginning of a 3-cell cage. Now the puzzle doesn't show us that it is a 2-cell 3 cage, but we know that a 3 cage cannot contain more than 2 cells. And the only possible combination for a 2-cell 3 cage is 1, 2. So we'll put those digits in. Next spot in the puzzle where we're going to make progress is down here in box 7. Same story here. We have a 4-cell cage of unknown dimensions, but we do know that a 4-cell cage can only contain 2 cells and has only one combination, and that combination is 1, 3. In box 4, we know that there will be a 1 in this box. We also know that there's going to be a 1 in either of these 2 cells and either of these 2 cells. And if we have a 1 in this cell, the 1 will be here in this cell. And if we have a 1 here, the 1 down here will be in this cell. So we know that there is not a 1 in the first 2 columns of box 4. We know that there must be a 1 in this column. And I'm going to make those, let's say blue. The next step is back down here in box 7. We have an 11 cage of unknown dimension. An 11 cage can have up to 4 cells. And that combination would be 1, 2, 3, 5. But because of the 1, 3 that already exists in that box, the 1 and 3 cannot be here. And the 1 and the 3 would have to be out here in box 8. And that's not possible. So we know that this 11 cage is not a 4-cell cage. It still could be a 3-cell cage, but we know that it exists completely within box 7. this 9-cell cage of unknown dimension could be up to 3 cells. And because it can only be 3 cells, we also know that it is completely contained within box 7. And we know, of course, that this 4 cage is completely contained within box 7. Since we know that all 3 of these cages are completely contained within box 7, we can use the rule of 45 to calculate the sum of the unknown cells. If we sum all of the known cells, we come up with 24. So the sum of the unknown cells is 45 minus 24, and that is 21. The minimum number of cells for a 21 cage is 3. And those all must be somewhere in box 7. We also know that cages cannot leapfrog cells. They have to be contiguous. So if a 21 cage must contain 3 cells, and each of these cages must have a cell next to it, we know that this must be the location of the 3 cells that contain the sum 21. I'm going to make these green. Now let's figure out the possible combinations for this 21 cage. And I'm going to come over here into box 9 and use this as a bit of a notepad. I'm going to make these green, and we're going to write all the combinations out. So if we had a 1, these 2 cells would need to be 20. That's impossible. If we had a 2, these would need to be 19. Also impossible. If we had a 3, these would be 18. Not possible. But we could have a 4. So there could be a 4. And with a 4 would need to be 17, which would be an 8-9 pair. If we used 5, 5 would sum with 16 to make 21, and that would be a 7-9 pair. And if we used 6, 6 would sum with 15, but since we already have a 6, only one of the 2 possible combinations for a 15 pair is possible, and that's the 7-8 pair. The 6-9 is not possible. We can't have 2 6s in any cage. So this would be 6, 7, and 8. Now, if we know there aren't any additional combinations. If we started with 7, we'd end up over here with this 5, 7, 9. If we started with 8, we'd end up here or here. So these are the 3 possible combinations for this 21 cage. All right, now this 9 cage. We know it is a 2-cell 9 cage. And we can limit the number of combinations, or the number of combinations are limited for us by this 1, 3. The only remaining combinations are 2, 7, and 4, 5. Similarly, this box 11, we know it is a 2-cell cage, and the possible combinations are limited by this 3. So it could be a 2-9, or it could be a 5-6. Now I skipped over 1. I skipped over 4-7. And that's because if we used the 4-7 combination in this 11, we would eliminate both of the combinations from this 9 cage. So we're going to leave the 4-7 combination out because it is impossible. It would be a cage combination conflict, and is not possible. So what can we learn from that? Well, one thing we can see is that there are no 8s in any of these cells in box 7 in columns 1 or 2. That means an 8 must be in these cells. If that's the case, then this possible combination, the 579 combination, is not possible because it does not have an 8. So we're going to mark that one as red. As it is not a possible combination. I guess I'm going to put them back in there just so we remember what they were. 5, 7, and 9. So let's move up to box 1. A 14 cage of unknown dimension. It could have up to 4 cells. And given that there's a 1, 2 here, we cannot have a 1, 2 in any of these cells. We would need to have a 1 or a 2 here if we needed to use that in our combination. So we would have to start with a 3. So 3 and 4 is 7, plus 5 is 12. So this could be a 3, 4, 5 if this was a 2. Now, I am going to mark this in orange as a possible combination and put another possible combination over here as a notepad off on the right side of the puzzle. There's another combination possibility, and that would be a 3, 4, 6, which would leave a 1 in this cage here, or rather a 3, 4, 6 here and a 1 there. Let's also look at the possible combinations of a 13 cage that might contain 4 cells. It also cannot contain a 1, 2 because of this 1, 2 here. And so the possible combinations for a 4-cell 13 cage are 3, 4, 5, 1. Let's also mark that as orange as a possibility. We do know, however, that the 3-cell cage can only have 2 cells. Now, if we were to assume that all of these cages that start in box 1 have all of their cells in box 1, we could use the rule of 45 to calculate the potential sum of the unknown cells. The sum of these 3 cages in box 1 is 30, 27 plus 3. And the remaining cells, the unknown cells, the sum of those is 15. Now, if either of these cages did have a cell that stuck out and was not in box 1, we would need to add that to the sum of the unknown cells and subtract that away from the 30. So if this was a 4-cell cage, we would need to have 16 in our unknown cells. And if we had a 14 cage where this combination 3, 4, 5 was used, we would need to have 17. If we had both of these that were 4 cages, we could have 18. And various combinations, but we need to remember that if there is a cell sticking out or 2 cells sticking out, we would need to have a higher value in the unknown cells. The point of all that is that 15, 16, 17, or 18 needs at least 2 cells. So whatever's left over, whatever size these cages end up being, we need at least 2 cells to fit a 15 through 18. What that means is that we cannot have both a 4-cell cage by the 13 cage and the 14 cage. In fact, one of these, for certain, has to be a 2-cell cage because we need 2 of the cells. We get 1 cell here from this 3 cage, but then we're either going to be here with the 2-cell 15, 16, 17, or 18, or here for the 15, 16, 17, or 18. If the 14 cage was a 4-cell cage, what could the rest of the cells contain? The 13 cage could not be a 4-cell cage, as the 3 and the 4 are already used, and since we need at least 2 cells for the remaining sum, the 13 cage must be a 2-cell cage. That is, if this is a 4-cell cage. A 2-cell 13 cage has 3 combos: 4-9, 5-8, and 6-7. With the 3-4-5-2 in the 14-cell cage, the 6-7 is the only possibility. That would leave an 8-9 in the pair in column 3. And that is not possible because we already have an 8 here. So let's look at that. I'm going to erase that, and I'm going to clear the numbers. If this was a 6-7, this would need to be an 8-9, and that's not possible because of this 8. So we know that this 3-4-5-2 is not possible. What if this was the 3-4-6-1? I'll get rid of this over here now. That changes the 13 cage and the remaining 2 cells. So with the 3-4-6, the 4-9 and the 6-7 are not possible. This must be a 5-8, which leaves a 7-9 in the 3 column for box 1. Now, this is also not possible, not because there's an 8 here, but the 2 combinations that have the 8 that are still possible for this pseudo 21 cage, one has a 9 and one has a 7. So this is not possible. So also a 4-cell 14 cage with the combination 3-4-6-1 is not possible. So I'll get rid of that and get rid of the orange notation. So we know that the 14-cell cage cannot be a 4-cell cage. It could be smaller, but we have cleared up the possibility of that being a 4-cell cage. What if the 13-cell was the 4-cell cage? That combination was a 3-4-5 and a 1. So if the 13 cage was a 4-cell cage, what could the rest of the cells contain? Now, the 14-cell cage would need to be a 2-cell cage because we do need room here and here for 15 to, I guess in this case, 16, because the 1 is the only option. So we have a 2-cell 14 cage, and the possibilities there are 5-9 and 6-8. Because of the 5 here, that forces the 6-8 here. Well, that's not a 6, it's a 4. Forces the 6-8 here, and that leaves, again, a 7-9 in column 3. And we just discussed how these remaining combinations that contain an 8, also one contains a 9 and one contains a 7. So a 7-9 combination is not possible. So we know also that the 13 cage is not a 3-cell cage. So what that means, besides the fact that we can get rid of the orange and those possibilities and get rid of these possibilities, what that means is that all of the cells within these cages are contained within box 1. Therefore, the sum of the unknown cells must be 15. And it must be at least 2 cells, but could be 3 cells. Now, what if the 15 cage, or the pseudo 15, was spread across just 2 cells? Is that possible? Well, the 8s here force a 6-9 into 2 cells, whether the 6-9 was here or the 6-9 was here. A 2-cell 15 cage would need to contain a 6-9. And once again, the combinations that this 8 represents, here and here, have a 9 and also have a 6. So a 6-9 pair is not possible, and neither are the 8-7. So what we learn from that is that this 15 must fit into 3 cells. That means each of these cages are 2-cell cages. What that tells us is that the 15 sum must fit into 3 cells. And it must be here in column 3 because each of these cages needs to have at least one other cell in the cage, and it must be next to what we'll call the parent cell of the cage. So I'm going to mark this in, let's say, pink. And this is a pseudo 15 cage. So what are the values in these remaining cages? What are the combinations for this 13 cage? The possible combinations are 4-9, 5-8, and 6-7. And let's put those in. 4-9, 4-9, 5-8, and 6-7. The possible combinations for a 2-cell 14 cage are 6-8 and 5-9. Now you'll notice that in columns 1 and 2, there is no 3. So we know that there must be a 3 in box 1, column 3, and the 3-cell 15 sum must contain a 3. But it also cannot contain a 1 and a 2. So that limits the possible combinations. So what are those? We could have a 3 and a 4, which is 7. So this would be a 3, 4, 8. We could also have a 3 and a 5, 3, 5, which is 8 and a 7. A 3, 6 would give us 9, and the next possible number up is a 7. 9 and 7 is 16. So the only possible combinations we have for this 15 sum are 3, 4, 8 and 3, 5, 7. Now, one of these combinations is not possible. The 3, 4, 8 combination is not possible because we already have an 8 here. So the only possible combination is 3, 5, and 7. With the 5 and the 7 now in column 3 of box 1, we can eliminate several of these possible combinations. So the 6-7 is no longer possible. Neither is the 5-8. So the 13 cage must be 4-9. And the 5-9 combination can be removed from the 14 cage. And now that we have a 7 in column 3, we can eliminate one of the two remaining combinations for this 21 sum. So we can get rid of this 6, 7, 8. It is no longer possible, so we'll make it red. So this is a 4, 8, 9. 4, 8, 9. And let's get rid of all of these here. We'll get rid of the numbers here, and we'll get rid of the colors here. This 4, 8, 9, I guess we could keep it green. I kind of like that. So what does that mean for box 4 in column 3? It means this is a 1, 2, 6. We need to add it to 6. Before we go any further in box 4, let's continue in box 7 and clean up some of the possible combinations for the 11 cage and the 9 cage. With the 4, 8, 9 in box 7, column 3, this 21 sum, because there is a 9 in these three cells, we know that the 2-9 combination for this 11 cage is not possible. So we'll remove the 2-9, and it must be a 5-6. We can also remove the 4-5 because of this 4 and this 5. The 9 cannot be a 4-5. It must be the 2-7. And now let's move on to box number 4. Let's see what we can do here. Find out the number of cells per cage and try to pin down some of the combinations for those cages. So let's start where it's easiest. A 7 cage cannot contain 4 cells. It can contain 3 cells, but it only has one combination if we assume a 3-cell cage. So let's rule that possibility out to start with. The only combination for a 7 cage that has 3 cells is 1, 2, 4. Let's pull the 6 out of that and the 4. Now, if there is already a 1, 2, 6 here, we cannot have a 1, 2 here. So this could only be 4 and would need a 1 or a 2 in here, but that's not possible because the 1 and the 2 exist in this 3-cell, was it a 9 sum? Is that what we decided? Yes, of course. 1, 2, and 6 make 9. So the 3-cell 7 cage is not possible. So it must be a 2-cell cage. Let's get the 6 back in here. And if it's a 2-cell cage, what are the combinations? Well, we could have a 1-6, which we know is not possible because it's already taken in the column 3. It could be a 2-5, but the 2's already taken. So it must be a 3-4 pair in the 7 cage. Let's look now at this 12 cage. We don't know the number of cells in the 12 cage, but we do know the possible candidates, and those are 5, 7, 8, and 9. Now, if we were to use 5, 7, 8, and 9, possibly with a 1 or a 2, the minimum that we could have would be a 5, 7 with a 1. That makes 13. So it's not possible that the 12 cage has 3 cells, nor is it possible that the 12 cage has 4 cells, because then we would need to use a 5-7, the minimum would be a 5-7-8 with a 1, and that's far beyond 12. So we know that this is a 2-cell 12 cage. And a 2-cell 12 cage has 3 possible combinations, 2 of which are eliminated by the 3 and the 4 already in the 7 cage, the 3-9 and the 4-8. So this must be a 5-7 pair. And what that leaves for this 18 cage of unknown size, I think an 18 cage can actually be up to 5 cells. But what it leaves is an 8-9. And 8-9 is 17, so in order to make this into an 18 cage, we need a 1. That forces the 1 to be here in this cell. So let's put a 1 in this cell. And we are correct. It is a 1. We know we are correct because when we put a 1 there, the fog lifted. We had this dynamic fog remove, and this is basically the point at which we would be if we had used the information in the newsletter. I'm going to undo that. I want to put the 6 back there and remove the 1 from this pair. This is a 2-6 pair. So this is the point where my solve and a solve that potentially uses the information in the Artisanal Sudoku Newsletter, volume 224, would get to. And one interesting thing we see is that this is part of a killer cage, and we do know that there are parts of that cage to the left that, I guess, validates our thought that this 8-9, which sums to 17, plus this 1, would lead to a 3-cell 18 cage. But we also see this, I guess, half of what looks to be an X. And we know from the rules that cells separated by an X sum to 10. So this is a 9, as 1 plus 9 sums to 10, which leaves us with an 8 there. And what we find here is that by entering the 8, we exposed these 2 cells in row 1. So that's the behavior when a cell is entered. If it's correct, the fog lifts from that cell, and there's a possibility that other fogged, dynamic fog cells can be exposed, and hints will be available in those. So before we move on, I'd like to do some cleanup. So, a lot cleaner. I'm happy about that. And now we can move on into, I guess, the right 2/3 of the board, since we're pretty well sorted out here. So, box 2, well, I guess it's row 1 in boxes 2 and 3. We have an 8. And if you look at this 8 cage, we don't know exactly how many cells are in there, but I think we have a hint. First off, we know that we can have a 2-cell 8 cage. That's possible. And we also see that in this cell here, I'll navigate away from it. it doesn't look like there's a boundary on the bottom of this cell. I guess I should highlight it. Doesn't look like there's a boundary here in row 1, column 6. So I'm assuming that this is part of it. And we know that an 8, there can be a 3-cell 8 cage. And because of this non-boundary, I'm going to assume that it is a 3-cell 8 cage. And a 3-cell 8 cage has 2 combinations, a 1-2-5 and a 1-3-4. Bottom line, there is a 1. Because of this 1, there cannot be a 1 here. So this must be a 1. And yes, it is. The fog has lifted and it exposed this 7 cage, which again looks like has 3 cells because we don't see a boundary here. But let's finish off this 8 cage. There's a 2 here. Because there's a 2 here, this cannot be the 2-5 combination. This must be the 3-4. So I'm going to put in a 3-4. And then come down here to this box 5 7 cage. A 7 cage can have 3 cells with a single combination of 1-2-4. With the 1 here, these 2 cells cannot be a 1. This must be a 1. This must be a 1. And with the 4 here, this must be a 2, which means this is a 4. And it is correct. We do have a 3-cell 4 cage, 1-2-4. But this 4 and this 2 help us sort some things out. First of all, the 2 resolves this 2-6 pair. This is a 6. And this is a 2. Whoa. Try 2. There we go. That's better. And once we're correct on the 2, we see that 6 cage pops up. We don't know the dimensions, but we'll get back to that. This 4 impacts 2 different a cage and a sum. So we can take the 4 out of this, and we can we can set this to be a 3 and this to be a 4. So that's resolved. Then this 3, we can remove the 3 from this 15 sum. All right, so I think we're clean, and we have this new clue to work with. So, is it a 2-cell 6 cage, or is it a 3-cell 6 cage? A 3-cell 6 cage is possible. We could have 3 cells, and there's only one combination, and that combination for a 3-cell 6 cage is 1, 2, 3. Now, this row helps us figure that out. Because there is a 1, 2, and a 3, this cannot be a 1, 2, or 3, and therefore it cannot be a 3-cell 6 cage. It must be a 2-cell 6 cage. Now, the possibilities for a 2-cell 6 cage are 2, 4, and 1, 5. And since we have 1, 2, and 4, we know this must be a 5. This must be a 5, and 5, come on, and a 1. Now, we didn't get a clue from any of those. So there must be another way to make some progress. So, what is next? We've finished this box 6 cage. After placing this one, we do have quite a few 1s that point here at box 8. So we have the 1s here. This might be an easier way to do it. We have the 1 here and the 1 here. We also have the 1 here and the 1 here. What that does is it forces a 1 into box 8 in row 8, column 4. So this must be a 1. Now, I don't think we've seen this before, where the one we expose, the cell that we expose by entering a digit, is also the clue that we get. But because of this 1, it is a 7 cage. And as discussed before and seen right here, a 7 cage can be a 3-cell cage. Now the question is this a 3-cell 7 cage? The answer is no, and we know that because the 4 is here. So we know that this is definitely part of this 7 cage, and we could also have any of these cells be part of it. But the max it could be would be 3 cells, so it could be a 3-cell with an upward turn, it could be straight across, and it could be a downward turn. But if it was a 3-cell cage, it would need to contain 1, 2, and 4, and we have a 4 here. So it cannot be a 1, 2, 4. So it must be a 2-cell cage, and the combination of a 2-cell 7 cage that goes with a 1 is 1, 6. So this must be a 6. Indeed it is. And we have exposed an 11 cage in whole. It's a 2-cell 11 cage in box 3. So what are the possible combinations of a 2-cell 11 cage? We have 2, 9. So I'm going to put 2, 9 in here. We have 3, 8, but this 8 prevents that. We have 4, 7, but this 4 prevents the 4, 7. And we have 5, 6, but this 6 prevents us from putting a 5, 6 here. So the only possible combination of this 11 cage is a 2, 9 pair. So what's next? We didn't get a clue, so there must be some additional way to find a cell. And in box 3, row 3, we have that. We just filled in these 2 cells. So where does a 1 go in the top third of the puzzle? We have a 1 here, and we have a 1 here. So the only spot for a 1 is right here. So let's put in a 1 there. And again, we didn't get any clues. There must be something else that we can find. So this 1, you can see it has no boundaries, no cage clue. It's just a 1. Now, setting this 1 adds to the many 1s that are already in the puzzle. And that will help us set another 1 in box 6. So we have a 1 here, and we have a 1 here, we have a 1 here, and we have a 1 here. All of those point at box number 6. And what that does is it forces a 1 into this position in row 4, column 8. Setting this 1 gave us 2 clues. First off, we know that this is an 8 cage. The bottom of this cell has no boundary, and of course an 8 cage cannot have only 1 cell, so we know it at least contains 2 cells. And it exposed this 6 cage, and the right side does not have a cage border, so we know that there's at least 1 other cell. We're certain because of this 1 and this 1 and this 3 that it's not a 3-cell 6 cage. We know that this is a 2-cell cage, and because the possible combinations of a 6 cage are 1, 5, and 2, 4, because of this 1, this must be 2, 4. And this 4 helps us resolve that, so we know that this is a 2 and this is a 4. So let's jump back up here and see what we can determine with this 8 cage. It is possible that an 8 cage could contain 3 cells. One of the combinations of a 3-cell 8 cage is 1, 2, 5. This 5 eliminates that possibility. So if it was a 3-cell 8 cage, it would need to be 1, 3, 4, which is the other 3-cell 8 cage combination. How would that work? Well, this 4 prevents it from being a 3, 4 or a 4, 3. This 4, 3 also negates the possibility of a straight shot 3-cell cage. There's a 4 here and a 4 here, which negates the possibility of a left-hand turn. I guess that would be right, depending on which way you're going on this supposed Sudoku, killer Sudoku road. Anyways, these two in column 7 and 8, we cannot have a 3-4 because of these two 4s. So if we were to have a 3-cell 8 cage, the 3-4 would have to be here. And the 3 would need to be there, and the 4 would have to be here. Now, is that possible? Well, it's difficult to say using 3s and 4s. However, these 2s help us solve that problem. So we have a 2 in row 4 and a 2 in row 6 and a 2 in column 7. That forces a 2 to be in one of those 2 cells. Now, if a 2 is in one of those cells, it can't have both a 3 and a 4 in those 2 cells. So what we do know is that these are not 3 or 4, but one of them is a 2. And if it's not a 3-4, then this is not a 3-cell 8 cage, it's a 2-cell 8 cage. And then this must be 7, which matches the 1 in an 8 cage. And this must be the 2, which helps us resolve this to a 9 and this to a 2. Now this 4 down here, we can get rid of the 4 there. Any more cleanup? I think we're clean. This 2 didn't give us any extra information. Neither did the 7. So there must be another way besides cages to come up with another digit. Now this 7 does help us come up with another value set into our puzzle. This and its sibling over here in box 4 force a 7 into this cell here in box 5, into row 6, column 4. This must be a 7. And that also forces an 8-9 pair into here in row 6. So the final 2 digits are an 8-9 pair in row 6. They're in box 6. These 4s here in column 7 and here in column 8 also help us here in box 6 by forcing a 4 into row 4, column 9. Then the remaining 2 cells in box 6 must be a 3-6 pair. Sticking with 6s, we can use these 6s here in rows 7 and 8 to place a 6 in row 9, box 9. So this is a 6, and that opens up a new opportunity for us, this 2-cell 15 cage. These 6s have something to say about which of the possible combinations we're going to use, and this 7 helps us resolve it. So this must be an 8-7 pair with the 8 here and the 7 here. From this point on in the puzzle, there's very little logic. It's mostly cleaning up and Sudoku. So I may speed up the video and play it in 2 times, 4 times, 10 times speed to shorten the length of the video. So there you have it. We've finished 91 by James Sinclair from Artisanal Sudoku. Don't forget to check out the link in the description to subscribe to his great newsletter. Every Monday, you get puzzles in your inbox that are this caliber, hand set, and very engaging puzzles. So I hope you enjoyed this. Now, if you're still here, you must have enjoyed this solve and appreciate the content. So I have an ask for you. There are 3 easy things that you can do to support the Killer Fun channel. First, you can click that like button. It's nothing but a click, very easy, yet YouTube promotes liked videos. The second thing you could do, you could subscribe to my channel by clicking the banner or the button. Again, it's just a click, but channels with more subscribers are given more features, and so I would appreciate you subscribing. Third, you could leave a positive or a constructive comment. That's a bit harder, but it's certainly less time spent making a comment than you just spent watching the video. Comments are another sign to YouTube that this is quality content, and they will reward engagement with promoted views. Plus, if you leave a comment, especially about the video that has substance, then I can know what I can do to improve, or I can know that I'm on the right course. So please consider 1, 2, or all 3 of these actions to support Killer Fun. Thank you, and we will see you on the next video.